Vocabulary. For this video, you really should be watching the pH scale part 1 video first, but basically we're going to cover the concepts of the hydrogen ion, the hydronium, the hydroxide ion, pH scale, and the relationship between hydrogen ions and hydroxide ions in acids and bases. For our understanding, we're going to be using an interactive simulation from fet.colorado.edu from the University of Colorado. They offer free simulations, and this one is top-notch to help us understand the relationship between acids, bases, and hydrogen ions and hydroxide ions. And here it is. If we have water, which is pH 7, it is neutral. What you'll notice, a few things that I want you to notice, I'm going to be drawing over here, are as follows. I want you to notice this H3O plus, you can be thinking mainly of as H plus. And the OH minus, that's our hydroxide ion. This H3O plus is the technical name for hydronium. It's also considered, you can consider it just the hydrogen ion, that H plus. So just ignore the 3 and the O for right now if that helps you, but basically H plus and O, H minus, hydroxide and hydrogen. Those are the amounts. And what you have here on the side is the concentration of the amounts. That's how much do you have of the H plus ions and how much do you have of the hydrogen or the hydroxide ions. And what you notice about these two numbers is that they're identical. They're small. If you know anything about the negative exponents and scientific notation, these are very small numbers, but they're the same. During the simulation, I want you to pay special attention to this area right here. What you're going to be noticing is that we investigate different substances, these numbers will change. We're also going to be noticing the pH scale right here in the middle. And this pH scale is going to show us the pH of the substance that we're looking at. Finally, I do want you to notice what you're looking at right here is just a pictorial representation or a graphic of the substance. It's not going to be perfect, but it's just a picture to get you an idea of like water. It looks kind of like this. Now, I'm going to do something which I think will help us, and that I'm going to turn on an image which will put the number of hydrogen ions, which are the red ones, and the hydroxide ions, which are the blue ones, on our simulation, so that you can see as we change the substance, the amount of red dots and the amount of blue dots, or the amount of hydrogen ions or the amount of hydroxide ions, will change. You'll see it here visually, you'll see it here on the graph, and you'll see it here on the pH scale. So water, again, so that you should know water is pH 7 and it's neutral. Pure water is pH 7 and it's neutral. It has the same concentration, the same amounts of hydrogen ions and hydroxide ions. Same amounts, equal levels, roughly the equal number of hydrogen and hydroxide ions here. If we were to investigate a different substance, let's say the stuff that's in vomit coming out of your stomach, out of your mouth, totally gross, what do we notice? Make some observations. You should notice very quickly the amount of red dots versus blue dots over here. Remember, red dots are representing our hydrogen ions, and the blue dots are representing our hydroxide ions. Notice the numbers. They changed drastically. In fact, our hydrogen ions increased a whole lot, and our hydroxide ions went down a whole lot. Also notice what happened to the pH. Stomach acid is pH 2. What can you say about acids and the relationship between the hydrogen ions and the hydroxide ions in acids? You should be able to make a note, or you should be able to make the observation that in acids, which are pH below 7, there's a more hydrogen ions than there are hydroxide ions. That's what was defined in the part 1 video. There's more hydrogen ions in acids than there are hydroxide ions. Stomach acid, or the vomit that comes out of your stomach, is a great example of a strong acid. It's an acid that's very acidic, and it has a lot of hydrogen ions, very few hydroxide ions. Let's look at pure water again to give you a reference point. Again, the amounts are the same between hydrogen and hydroxide. Now, if we were to go somewhere on the pH scale that was basic, let's look at drain cleaner. The stuff that you put down your drains to clean all that rotten hair that's in there. What do you notice? Another extreme example here, but you should make an observation. The pH is 13. A high pH represents a base. A low pH represents an acid. This is pH 13. It's higher than 7, which means the number of hydroxide ions is a lot higher than the number of hydrogen ions, which is illustrated in this graph and which is illustrated in this image right over here. You see the blue dots are represented as hydroxide ions. There's lots of them, and there's very, very few hydrogen ions in this solution. That's because a base has a higher concentration or more hydroxide ions than it does hydrogen ions. And it's that way for every base. In fact, if we were to look at something that's like blood in your body, roughly basic, it's slightly basic, it's just above 7. Notice the hydrogen ions are slightly less than our hydroxide ions. Also, the image looks red because it's blood, but you notice there's kind of some more blue dots than there are red dots. If we look at something that's slightly acidic, like soda pop, or let's look at coffee. Coffee tends to be acidic. Acids have more what? Hydrogen ions versus hydroxide ions, which is why the number is taller here and shorter for the hydroxides. Also, the number on the pH scale goes down as you go toward acids and goes up as you go towards bases. We can change our substance. It'll become custom as we change our pH scale here. I want you to be paying special attention. We're going to go back to 7, or roughly back to 7 here. Let me go back to water. I'm going to drag the pH scale, and what I want you to notice is I want you to notice this on the side. On the right-hand side of your screen, I want you to notice the number of hydrogen ions and hydroxide ions. Just notice what happens when we go more acidic. What happens to the number of hydrogen ions? What's happening? It goes up because acids have more hydrogen ions. Bases, now we're going to go back to 7. As we go towards a base, what happens? That's right. You should be paying attention. The hydroxide ion number of them, or the concentration of hydroxide ions, goes way up, and the number of hydrogen ions goes way down. This should make sense to you. This should make sense to you because in pure water, H2O will break down to form hydrogen ions plus, that should be an O, hydroxide ions. In an acid, remember, the H plus amount is greater than the hydroxide amount. The hydrogen ion amount is greater than hydroxide, and in bases, it's the opposite. A base has more hydroxide than hydrogen. Or you can say it has less hydrogen than compared to the hydroxide. Just depends on how you talk about it. So you should understand, as a review, an acid, what an acid is. You should understand what a base is. You should understand the pH scale. You should know common substances and their relative pH. Also, you should know how are H plus and OH minus, the hydrogen ion and the hydroxide ion, how are those amounts related with neutral solutions, acids, or bases. This is Aaron Willems. Thank you for watching, and do your best to make a positive difference in somebody's life today.